In class today, I came up with some really good ideas on how to make logarithms somewhat simple. And what I've done is I've given you a relatively simple logarithm chart here and asked you to plot the log of a number against its logarithm when we take the logarithm. And so I'd like you to right now, before you do anything else, just get yourself a little graph paper or make a modified graph paper and plot these points that you see here with the numbers across the bottom and the logs up and down. Turn off the recording and give that a shot. Now that you've taken the time to actually do the plot, you'll see it should look something like this. If it doesn't, you need to go back and rethink or make sure you understand how a graph is made. But this is what we see. And what I wanted to show is how these numbers progress. So now as you watch how this thing progresses, it's kind of interesting. And this is what I wanted you to see about logarithms. When we start, let's try and get that to stay up. There we go. Okay, when we start at 1, and we go to 2, you'll see that I'm up about 4.5 millimeters, or yeah, 40 millimeters. Yeah, about 4 centimeters. Okay, about 4 centimeters up, 4.5 centimeters. When I go from 2 to 3, okay, we're at 2, we were sitting here. And at 3, we're up only 3 centimeters, a little less than 3. As we go from, about 2.5, 2 3/4 centimeters. As we go from 4 to 5, starting out here and going to here, oh, no, we're not starting out there. We're starting out here. Here, going from 4 to 5. Okay, we're here, and we're going to here. We're at 1.75. And when we go from there to the next one, we're going less than 1.75. And when we go from this level to this level, you notice the amount of distance that we're going vertically is constantly getting smaller. Okay, because we're starting out here and we're going to here, and we're getting less and less every time we move up. Okay, from here to here. And as we make the final move, going from here to here, we're dropping into less than 1/2 centimeter. So we started out moving about 4 3/4 centimeter for each whole number. And then the log moved up 0.3, from 0 to 0.3. And at the end, we're moving up from 9.5 to 1, and we're only at 1/2 of a centimeter, or less than 1/2 centimeter in the improvement there. So what are we going through this for? Because these guys will also give us another hint of what that means. These are the normal numbers, and these are the exponents, which is what you have to deal with pH and pOH, and the concentrations of hydrogen or hydroxide. So if we have the concentrations here, we go 10 to the minus 12. And so as I'm going down here, I'm at 10 to the minus 12 until I get to this 10 times 10 to the minus 12, which we rewrite as 1 times 10 to the minus 11. And so my numbers are actually getting larger as I add these guys. And somewhere along the line, you got to realize that these numbers, when we take the log of them, have to be subtracted from this number that we're going to take the log of. It will make more sense in the next slide. Here we go. What I've done is given you estimates. This column here represents the log of the number out front here. So this is the number out front. This is the logarithm here. This is the only thing that you would really want to put on your help sheet to help you with what we're going to be doing today. And of course that will be on the quiz. So I've got 1. If it's 1, it's going to be a 0, which you're already familiar with because of this thing right down here. 10 to the x is equal to x. But when we're taking, and that's the log, okay? The log of 10 to the x is x. But the log of this guy, which is the number out front, when we have a number like this, 2.56 times 10 to the minus 8 or 4, whatever that number is. Okay? The log of this part is 4. There's the log of the other part. That's what we have to account for. This is easy. You just change the sign and you got yourself the logarithm, because that's the definition of a log. It's the exponent of 10, at least in base 10. In other bases it's different, but for base 10, that's what we're working with. Now, this guy here is going to have to be estimated. So what would we have as an estimate for 2.56? How do you figure? No, it's between 2 and 3. So what's the log? This is the log. Come on, 2.56. What is it? It's 4.4. Yeah. Okay. Let's take 8.3. 8.3. That's in this range. And so that would be 0.9. Yeah? If I said 2.9, I'd be in this range. And the log would be minus 0.4. Okay? Now, the only thing that's a little bit of a cute thing, so to speak, is when we're taking the log of this, we're not just taking the log, we're taking the minus log. And let me get the screen up, or the shade up here, so we can concentrate on one thing at a time. With the way you're given concentrations, there's always a number out front. Okay, it's going to be anywhere from 1 up to 9. But that's all it can be, because we work in scientific notation, right? When this number gets bigger than 9, we move the decimal over and adjust the power of 10, right? So let's see what you've been doing in all of your homework up to now. You take the minus log of 0, and what do you get? Yeah. The log of 1 is 0. So the minus log of 1 is also 0, because that's what it is. Now, what's the log of this part? Come on, what's my second log? 4. Minus log of 10 to the minus 4 changes the minus 4 to a plus, and 4 is the log. So it's 4. You've done about 10 or 15 of these problems, maybe 20. So here's what we have. Minus 0, which we don't have to worry about. Remember, this is a minus log. And the minus log of this guy up here turned out to be a 4, which is infinitely accurate. So 0 plus 4 is 4. Now, I didn't make you show that before, and I'm not asking you to do it now, but I want you to understand what's going on. Things haven't changed. It's just I didn't want to take you to this step until you'd had experience with something else. Now here you go. 3 times 10 to the minus 6. So this number is my first thing that I have to take the logarithm of. All right? And notice that we're adding this number to this number, but this will always be a negative number, so we're really subtracting, right? So in logarithms, multiply works out to be add. So here we go. The minus log of 3 is minus 0.4. Can you all see that on your chart? Yeah, okay. And then we're going to add, the power of 10 was 6. So we have both of them together is 6 minus the 0.4 that we got for the number of out front, which is the first, what I'm calling the first log. And so it's just 5.6. Really simple. All right? And now let's go down. Let's do another one together. Practice problems. What I'd like you to do is copy down this practice problem, stop the recording, and work it out. And see if you can come up with the same number that I come up with. I found out as I was working with my class that some of the people did not write down this little chart over here. I set it up so that we could see both pages at the same time. You need this chart. So when you do my practice problems, you want to be looking at this chart. So you want to write that down right now if you don't have it already. And I will actually make it a little bit bigger for you right now so you can see it more easily. And then take whatever time you need to write it down and then continue the recording. Now that you have this written down, get it on your help sheet so that you will do well on the next quiz. All right, here we go. Let's try another one. All right, here's your next practice problem. Okay, let's do this, guys. See how you do with it. Turn off the recording and calculate it on your own. That way you're going to learn something. Okay, let's hope that you got 2.1. If you didn't, let's split the screens again and let's look back at what that meant. This 8.4 is taken over to this table right here. And on this table, we're seeing that it's in this range between 7 and 9. And that makes the logarithm 0.9. And the logarithm of 0.9 is what we used over here to subtract from the 3. The 3 came from this guy. When we take the minus log, that becomes a 3. Infinitely accurate. Okay, let's try one more. Actually, there's 2 more for you to try. So let's go ahead and run this guy and turn off the recording. Try it on your own, or you won't learn it. I promise you. Try it on your own and then check the answer. Okay, for those of you at home, I was just helping my class out, telling them that 2.9 times 10 to the minus 6, the 2.9 is between 2 and 3. And the value of that is 0.4. Okay, so this is the log here. Okay? And this was the number out front. So, coming back over here, we're going to be subtracting the 0.4 on the right side here from a 6. And so your number should look like this. Okay? That's the third practice problem. And we got one more for you to try. Turn off the recording and try this one on your own. Okay, 6.3 times 10 to the minus 13. Stop the recording. By the way, to get the correct number here, we wind up using a 0.4. Okay, I had a 0.3 in here, and when I use 0.4 there, it would actually be 5.6. So I had an old chart that I modified and made it more accurate, and that's the result of that little error there. I apologize for that. Okay, let's go ahead and continue and try to do the best you can on this problem. 6.3 times 10 to the minus 13. Now, I was just telling my class that this 10 to the minus 13 is always going to go no matter what's up here, because this will always be in scientific notation, and it will never be 10 or larger. It'll always be less than 10. So when we're doing this, and in fact, it'll always be between 9 and 1. Has to be, because it's in scientific notation, always. So this 13 will go down to a 12 every single time, no matter what the number out here is. Okay, so let's see how you did with that problem. Here it goes. Both of them together is 13 minus 0.7, and the 0.7 comes from right here because it's between 4 and 6. Oh my, that should be 0.9, shouldn't it? Good, it's not between, not between 4 and 6. It is actually between 7 and 9. So that would make it actually a 0.6, or 0.9, I'm sorry, 0.9. And then the number over here is going to be a little bit less than I had said. Yeah. Okay, so that would be 0.1, 12.1. Okay? And that's it. I hope you find this helpful. You should really be a whiz at doing these now. So long. One other thing I wanted to add on. Let's go back and make this page over here a little bit larger. Yeah, there we go. And now I just wanted to make sure that we understand that when we're looking at this column, this is the log. When we're looking at this column, that's the number out front. And the number out front in all of my examples are the numbers that are over here, okay? This is the number out front, and this is the power of 10. That's it, folks. Have a nice evening or morning, whatever it is when you're watching. Bye-bye.